How's it going, everyone? Welcome again. Eulio Gonzalez here, looking right now at the front-end system design, where this is a course taught by Yvonne Ray, a software engineer that has previously worked at JetBrains over 3 years, and now he's currently working at Meta. And the whole point of this course and in today's video is that first we're gonna see at the fundamentals for UI specialists to know when you need to build a web scalable front-end application. Why this is important, and this is what we are going to look at in today's video, by actually getting a hands-on approach, especially with the web API, particularly the Observer API, specifically the mutation. Make a quick recap of the intersection, the mutation, as well as the resize here. So the idea here is that in this video is to recap everything that we have learned so far, so we can now be able to describe not only the fundamentals, but also the problems that we as a UI specialist needs to provide to companies. And once we acknowledge that, now things have started to be more interesting. We have much more meaning about the work that we're doing and the value that we are providing to companies, as well as to improve their business outcomes and this relationship. So, because I'm gonna make a quick recap of all of this series of topics that we have learned so far, especially first the introduction, as a way to understand that how can we design my bad. All right. As a way to look at what is the anatomy of these applications, okay, which is made of the backend, the API, and the frontend. In our case, we're going to now take a look at how can we create this frontend design systems and what is the component for this. So by looking is at the way of how you can now communicate with your application, which is one of the components of the front-end applications, as well as how you're going to manage and how you're going to store and manage the data, which is data management, and also how you're going to deal some of this user interface or this user interface interactions. And then we are going to see what are the most common user interface that when we need to build an applications for business, their interests on that. So for example, like how you can make is measure the analytics, especially as the user is navigating through your applications, or loading component as it is in a way that is performance, as well as how you can, for example, if that particular client needs a text-rich editors or a drawing tools, how can you now, by using the browser and this mechanism that they provide to you, so for example with the Mutation Observer API, how that is now much more convenient to build these kind of features for this kind of use case. And also when you need to, for example, is provide some functionality to drawing and for drawing tools, let's say for visualization most of the time, or as well as text rich editors or graphic tools, or guarantee the responsiveness of your applications, right? That not only works on the web but also on tablets, mobile, and so far this kind of device perhaps when we can or when the browsers companies can now provide a browser for their wearables, we also will need to actually discover those use cases. But in any case, the idea here is to recognize that, also to gain some perspective, that writing a browser is something that is not easy. What does it mean that? For example, if we take a look at the Firefox line of code, okay, engineer exact. Actually, to look at this, because now Firefox is not using its GitHub to host their applications. In fact, they're using some sort of versions to host that, so you can have access to that. And you can see that the line of code of a browser is 31 million, more than 31 millions. What does it mean is that building a browser, building this application that is going to convert HTML that it receives from the network files in this particular format, HTML, CSS, and JavaScript, and then it transform that into pixel on the screen, okay, it's not easy. And this is something interesting as a way to get perspective of this, right? So this actually was the most active year, all right, in February 2017, as well as July 2017, April 2020. I think most of the time was like some security issues, perhaps, who knows. And as you can see, there is a peak here of that. So as you can see, as the year progressed, and this is something lovely to see, right? Primarily is using now C++ and also JavaScript. As you can see, is 10 million lines of C++, as well as 10 million lines of JavaScript, more than 4.5 million lines of HTML, 5 in C. Interesting that is Rust also has now 10% of the code base, and that's quite interesting, you know, and that's quite interesting. They're using Perl, they're using ECMA, you can see. All right, this is a very interesting website as a way to gain a little bit of perspective of when you are actually telling to the browser to do the thing that it needs to do. In this case, is that how important is, as a front-end developer, to understand that how the browser treat HTML and how that now is by putting boxes around everything, okay, via CSS. That's why we have now the box model, which is actually implementing is on this more than 31 million lines, okay. So this box anatomy is something helpful, especially when it comes to now tell the browser to render these elements, especially the HTML tags, and how this box, or this, what is the box anatomy of this, which contains the content, the padding, the border, and the margin, and what is the properties of this box, okay? So you have now per size and per type. So per size is as a way to calculate is the size of this box, whether it's intrinsic values based on its content or restricted, based on a set of rules that you have to apply to this. You can apply, or it is applied by other factors. So here we'll also look at the box type as a way to now see how the browser, when it treats now elements with the type block or inline, has a particular set of rules which participate in something called as the formatting context. So this formatting context is something, or the key aspect of this is it not only allows us to isolate all of these elements, other elements are not affecting how it's going to be the dimension, the size of this box, but also it is scalable because you can define different type of context or formatting context: block, inline, flexbox, grid. Okay, and then you decide, and then you define, and then becomes now scalable and predictable when it comes to know which one of these particular format you want to apply. So that's something interesting, because when we are going to know how the browser position elements on the screen, okay, here we actually look at particularly the example as a way to do that. When we need to tell the browser how this element is gonna put, okay, remember, over this more than 31 million line of code, oh my god, that's a country, bro. That's a small country, right? Is the size of Colombia, 10 million less than Argentina. You know what it means? It's like if one of those lines is a person, so we're talking about now is a country of the size, was a small size. So, oh my god, perplexity. Countries with 31 million people. Nepal, Yemen, and Madagascar. Really? Approximately 31 million person? Total population by country. Oh, well. Yemen. Jesus. Nepal and Madagascar. Okay. 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 Jesus. All right. Anyway. This is total lines, but code line is actually what really cares, because you have now total comment line, which is not actually what it is. What really matters is this total code of line. Okay. You have more than 6 million of comment line, and almost 5 million of total blank lines. Jesus. Anyway, but yeah, so on this huge amount of code, there is actually a particular way of how the browser is going to put all of your elements, the browser position systems. So by default, you have now the normal flow, okay, where it put all of these elements is top to bottom, or left to right, and then top to bottom. Okay, this is the particular algorithm it follows. And then you can change the normal flow by using properties like positions, relative, and static, or when you need to use some of the how do you put it? The 3D transformations, right? So why this is important? Why this matter? Because this stacking context, which is something that the browser create anytime you want to create now, or when you want to change the normal flow by creating this stacking context using this set of property, you can not only isolate it, which is one of the property of this, but also is to make or let the browser do some optimizations of that. So how you can do that? Well, by using it, for example, city transformations. So the thing here is that this optimization that you can do is important, especially relevant the more elements you need to actually show to the user, or the more elements that user needs to interact with in the document. Why is this? Because for example, huge applications, okay, like the so for example, like social media, or any any heavy user interface with a lot of interaction, any heavy interactive web applications, e-commerce, social media applications, and that kind of things. Also is drawing tools, text-rich editors, a lot of visualization that you need to show, for example, for trading applications. When you need to have these kind of things, you need to be aware of how you can harness the full power of the CPU. And that is by understanding is this critical rendering path, which is the way of, as I mentioned before, how the browser now treat HTML, CSS, and JavaScript into pixels on the screen. And then it transformed them into the DOM, the HTML as well as the CSS into CSS object model, merge that into render tree, which contain all the necessary information for those elements and how it's going to be displayed, but it doesn't know where to put it. And that's when the reflow phase happens, which is the process in the browser around this. In the case of Firefox, more than 31 million line of code, right? It's a, hey, this is how we're going to treat this. This is how, for example, we are going to, what in the mother of French toast is happening to me, man? You know what? Sorry. All right. Okay, my bad. Anyway, so here we are, right? So yeah, this is the important thing of knowing these things about reflow, right? And well, at the end of the day, okay, yeah, at the end of the day, it's like how this particular process, the reflow, actually is now going to put all, is going to calculate is the position and the dimension of all of these elements that you specify, right? So this is something that is usually triggered by JavaScript. And then when you, for example, change this property that I mentioned before, now it needs to also trigger is this calculation or this reflow, as I mentioned. So that's why the call of reflow, okay? But you can now optimize, or you can prevent that phase happen, and only happen is the paint and the composite phase by using some of these CSS classes like transform, where instead of mutating is the property, the dimension of the position of these elements, now you are talking directly to the CPU to do that. So the thing is that in this composite layer, which is after the browser now know what are the things that I need to paint, it has all of this in memory. This is all the things that I need to paint. Now the browser need to know is how all of these different paints are part of the page and put it together to display on the screen, right? So this is part of the composite. Back in the old days, it was using CPU. Now it is using the GPU to do that, all right? And as we can see here, we can look at now how is the process of this composite layer. So you have now the render object, which is something that is being used and to match one-on-one with all of these elements, all right? If you create a new stacking context or a render layer, what you're telling now to the browser is to say, hey, this is a particular layer that I'm going to use in any of these elements. I'm just only gonna call is this most top elements here. Not only that, but also you have the graphic layer, which is when you use, for example, is 3D or perspective transform, video, and canvas. They actually make use of that. So far so good, right? So far so good. So with this understanding, at least of not only how Firefox works, but also browsers in general, Chrome and Firefox, right? As a way of how now this specific fundamentals of the browser, how it treats HTML, and then how now it creates this formatting context, and how that is connected to the stacking context, and how you can harness the full power of the GPU when it comes to create multiple layers to display that to the user, all right, in the most fast possible way to improve the user experience, and what is the inner mechanism that's happening behind the scenes. Now it is time for us to build this user interface. And before that, we need to first look at the DOM, which is the way of how we're going to create this document. And the DOM is this model, document object model, which is a representation of the DOM, which is this node tree, which is this DOM tree, right? And this DOM tree is actually, this tree is a way of how you can organize data in a computer science. So you have, for example, hashes, or that can act like a records, right? So you have hashes, you have now arrays, you also have linked lists, double linked lists, stack, queues, as well as trees and graph. All of this is a specific rearrangements of elements, a particular geometry that these elements have to operate on these things, and they have several trade-offs. So in our case, the document object model is organizing in a tree-like data structure, in a tree binary data structure, okay? So we need to look at what is the anatomy of the DOM as a way to refresh this DOM API. And this is useful, especially if you want to build these low-level libraries, okay? So for example, like virtualization or state management, that kind of thing. And also, if you want to, or if you need, for example, to work with components like video players or chart engines, okay? Or you want to just build your portfolio with a minimal app blueprint, right? So for that, we need to understand is now what is the object that we can have access to, at least from the DOM, that they provide us. So you have the window, the document, the body, and the head, and how the DOM is organized internally, which is the class hierarchy. It all starts with the DOM, with the node, okay, which is actually the how the data is represented, right, in a tree-like data structure. And then know that this is an abstract class that other classes use as a blueprint, right? So for example, you have the element, you have the text node, you have the HTML document, and then how from the element you can now inherit or you can now extend, all right, all of these different specific types of elements. So for example, like HTML elements, or so you have HTML elements. We can also see the elements here, the elements in MDN. So HTML element, SVG element, math elements as well, or any XML element that use this interface. But yeah, this is, let me see, it's actually, they describe here in a more deep sense: DOM standard, pointer event, full screen API. The document object model, no, okay. Specs, events, instance, and instant property. But yeah, well, this is actually how you can, so from the element, which is this base class, that other elements inherit property from this. So for example, like HTML element, SVG element, math element. This is just as a way to understand that, and how the HTML elements inside of that, it represents any HTML element, all right? And by any HTML element is like, hey, it can be a head, title, body, header, footer, that kind of thing. All of these HTML tag that I mentioned before. And that include is, for example, is multimedia embedding, tables, forms, use HTML to solve common problems. Some of the advanced topics, for example, in course setting attributes, the HTML reference as well, which is something that we were looking for here as a way to see, well, what are the elements, the HTML elements that we can use, right? So yeah, this is it, right? For text content and inline semantics, image and multimedia. So this is quite interesting as a way to recap of this kind of thing, right? Embedding content, right? SVG and math ML, scripting, even with Canvas, the marketing edits, table content, forms, interactive elements, web components, right? Obsolete and deprecated. But the whole point of this is that from that element here, okay, from that element, specifically the HTML elements, we can now in their more than 30 million line of codes, this is one of the things that they provide to us. So for example, like metadata, right? In sectioning, how we can organize our applications by sex, or this document by section, the content inside of that, the text, inline text semantics, image and multimedia, embedding content, SLV, scripting. So all of these things that are very, very interesting, this is not what the browser allow us to do. So Because of that, we need to know is how can we, what are the most common, what are the operations that we can do to the DOM API? And that is, well, querying the data. All right. They don't actually mention about this kind of operations because this is more about is talking the yeah, this is more about talking the yeah, but this is more about talking is on the guys, content categories, block level elements, inline elements, query data, constraint validations, micro formats, viewport meta tag. Viewport meta tag, that kind of thing. Allowing cross-origin use of image as well, storing an image for from a foreign origin, implementing the save features, starting the download, and there you got it. Okay, web storage and API. But yeah, this is a guide. Uses the HTML, introduction, multimedia HTML tables. That's quite interesting. Yeah, content categories. Because it doesn't tell you about how you can now interact with HTML, right? Very interesting. How you can interact with that. And okay, no problem. Well, in any case, if you want to build now this user interface, okay, we need to know is at how can we interact with these DOM elements? How can we manipulate these DOM elements, right? So first is by querying those elements. Hey, I want to get this particular element, access to these elements. So you have the get element by ID. You also have is the get element by tag name, by get element by class name and tag name, query selector and query selector OR. I'm going to make a quick recap of each one of them because get element by ID, despite that this is that has the best performance, is an anti-pattern when you use that a lot, especially because you somehow need to have a record of all of this ID, or some of these elements will break, right? Or you can't have access to those elements, not in the way that you expect. The other is a get element by class name and tag name, which it return is a live HTML collection, which is something that the way how it access to this element, or you get that element, is by running this DFS plus a hash table, this deep first search and the hash table, something that I definitely need to see how these things work, right? The DFS. I barely remember how can I do that, but I think this is something important, especially as I build more and more my knowledge here, right? Yeah, basically is that kind of thing. So so yeah, we got is this get element by ID, and get element by class name and get element by tag name. Despite that this is the a low overheat, because you don't have, it doesn't create a copy of that. You have access to the this real life DOM. So there's some problems in there, especially when you need to iterate through that through this live collection, and that has shown over the couple years that that was not a good approach. That's what we have now is the query selector all, where the query selector, again, using its DFS plus a hash table. So once he find that element, next subsequent queries for that particular elements, because the browser have some inner catching mechanism, one of their more than 31 millions, okay, line of code, Jesus. So yeah, you will get that. So okay, one of the thing here, okay, is that on this topic, all right, what we're talking about is now to get the query selectors, as well as query selector all, which now return you is a collection of nodes elements. This of course has a higher peak in memory, or has a higher overheat in memory, because it now create copies of this object. But this has been proved that is a good approach despite that. And the other is the query selector all, which is something that I already mentioned. Again, some of the best practice when using this is that if you're gonna use the ID, you better put that in the right place where you can get that element or that collections of elements. All right. And the other optimization or the other practice is that use query selectors. We use small query selectors, simplify query selectors. So all right, we also look at how messy is this thing, especially when we need to add elements or remove that. Honestly, they are worse in all cases. The less worse of all of that is when you do the append child, all right, to this element. All right, so instead of the inner HTML, where you have is where the browser needs to parse this entire text that you're passing and then convert it into a proper element on the node, on the tree, right? You don't have to do that with a append child. You just only pass that element. Again, you're making that this over 31 million line of code, you align to this. You align to how this more than 31 million line of code actually works, and make it easy for that as well as for you. So this is pretty much like you are not going to use, if you have a motorcycle, okay, or if, a good example, if you have your cell phone, you're not gonna let that cell phone charge always. All right. So there's some reasons why you shouldn't let that happen. Pretty much, especially here with this adding elements and as well as remove elements. So you have now the inner HTML or the remove element. So far so good, because once we started to look at particular example, especially how we can create now a UI element, especially a car, simple element, a car, right? By using this document fragment, and then we define is now the template, which is the way of how we tell the browser, all right, this more than 31 million line of code. And I know I'm repeating myself here, but I just wanted to transmit the feeling of this 31, this more than 31 million line of code, writing it, okay. So because of that, all right, here, this is how we tell the browser, hey, these elements that we're going to define under the template, please don't show them. We're going to access to them at runtime with JavaScript. Okay, so this is exactly what we did. So we get this element, right, and then we populate that with proper data that we see fit. And the way to populate that data here is by actually is not only get access to the content and clone that node, okay, to create a new copy of the first element child. So we can now have a reference of all of this, the HTML structure, but then find them in this sub-tree element, on this document fragment, in this subset of set of the DOM portion, the DOM tree, is to find in this subset of portion this element, all right, and then let's going to now update their values with the text content for that. So this is something quite interesting, very, very interesting. So once we run this, then we want is to mount that. Okay, so the way to mount that is we say, hey, I want to now mount that in the ID container. So this sub-tree elements, I want you know to mount this here, which is exactly what we did here, right? So the container, with the container here is this, get element by the container, and then we mount this element here. So a real life example of this is something that I got, yeah. Yeah, a real life example here is the one that I have in the code sandbox here. Okay, that's quite interesting. DOM API performance, HTML collection example here. Yep. There you got it. Okay. And voila, you're quickly gonna see that. Let's take a look at the preview. And in this example, you say, hey, no, we couldn't run this. And to me, it's like, why? Why not? Why you're so silly? It's because it's running here. Wait, what? What? This is, come on, man. What the French toast is this? DOM API performance. Okay, DOM API performance. Like this. Is this one? Is this one? DOM API performance. Okay, good. So now run the preview, and then you are able to come on, man. Start from the editor. Authenticated. Why there is someone else? Oh, what the? Jesus. Run. Okay, that's right. Open the preview, and we're able to see now this specific UI element, this card, right? You may wonder, yeah, it's I can do that in React in less line of code, but the thing here is that we are now using is the native instructions of the browser as a way to build this, okay, in a way that we can now align to build things in the most performant way with using the web technologies right now. So this is quite interesting because this is also helpful, especially if you're going to work on WordPress, on PHP, and that kind of thing. So now we're starting to exploring is what actually, this is where one of the values that front-end engineers or UI especially provide, which is, well, how we gonna use this web API to build some complex UI patterns. So for example, by relying on the observer API, which is unlike the normal event-based pattern, right? This particular patterns behave specific according to our needs. And then we have is the intersection, the mutation, and then the resize. So as I mentioned before, the intersection serves to a particular purpose. Most of the time is for virtualizations. So as a way to show is infinite scrolling. Okay, so virtualizations, lazy components, dynamic components, as well as for analytics. For example, it's like, hey, how many times a user is actually, for how long a user is looking at this particular section or car, right? And that kind of thing. So this is for marketing, for analytics, and this is part of the intersection observer. Pretty straightforward. The intersection observer, what it does is to see if these two elements actually overlaps, because back in the old days the way to do that is by calculating is the position of these elements, okay, by get that element by creating is by detecting is the rectangles, these boxes, okay, and then calculate that every 10 millisecond or an X amount of millisecond as a way to see if they're overlapping. If it is, execute the callback. So because that is something that is of course not performant, because now you're using the callback queue exclusively for handling is this observer or these intersections. Now the spec developers say, hey, well, it is better for you to so we're going to provide you now a particular queue to actually is look up at the when these elements intersect. All right, and if you, for example, don't specify any elements at the root, we're going to assume that you want us to now compare is the viewport when that overlapping to these elements. So when when the viewport and the boxes actually overlapping, which is most of the time what we want to do. But the whole point of this is to detect when these two elements happens. Okay, so for example, if they're doing some kind of animation, if they're moving around that, detect when those elements happen. Okay, so we can do something about it. That's quite interesting. Yeah, that's quite interesting. Yeah, that's quite interesting. Okay. So the thing here, the setup of this intersection observer is that you're going to define is the callback as well as instantiate the intersection observer, where you're going to provide is now the callback as well as the options here, which is pretty straightforward. This option is to indicate what is the threshold to trigger this callbacks, and inside of your callback you're going to receive is the number of entry, which is the number of event that is triggering every time that these two elements are overlapping. Okay, and to do something, right? So in our particular case, when we are building is this car, which is where we are here right now. Let me see. Exercise and real life example. yeah, this real life example where we have now is the change branch to intersection API. All right. So the idea here is that when these elements overlap with the viewport, we want is to create all of these cards that we're getting from the server, creating all of these cards, all right, and then creating all of these cards on the fly, and then append that to the DOM so the users can see that. So now, by creating these elements on the fly in JavaScript and then tell the browser to append, it will now have all the necessary data to not only know what is the element that it needs to apply, but also its position by calculating is this reflow. So when you append these elements, you are telling now the browser to rerun this reflow. So, which is pretty much what we did here. Right? As you can see, when we reload this, it actually loading all of this, which is quite interesting. Okay, and as you go to the bottom, it do that the same thing as expected. So that's very interesting as a way to create now this specific infinite loading screen. All right. And the way we did that is by using the interceptor observer. Once this element is intersected, we're going to create on the fly, or in this case, we're gonna get all of the data that it is, okay? And then we're going to create on the fly using a document fragment, okay? And instead of us having to create that in a string, we just only have that element store on the HTML, okay, on the document. We get that element for that on the document fragment, okay, and then we're starting to create all of these elements here with all the proper data as it is, append that to this fragment, which is a subset of nodes of elements here, that then we're going to append to the entry point in or down node, right? Which is something that we did here as it is. So we append that on the list, which is something that we get here with the document query selector all, right? So hey, get me this and list and that kind of thing, right? And we're using as a query selector all in this case. And remember, the simple the query selector, the better off. Okay. First you need to define is the callback queue, or you need to define the callback, then pass that callback to the intersection observer object, where you're going to define the second parameter is the configurations of how this element is going to be overlapping, at which ratio this element is going to be overlapping, and when that happens, well, I want you to trigger this callback, and you need to tell which element you want to observe. Where in our case, we want to observe is this element here that we define here, the bottom observer here, right? So when we reach to that bottom, or when the user reach to that bottom, okay, it's like, okay, it is time to create this. It is time to trigger this callback, which is creating all of these elements. Which is creating all of these elements here on the fly using the document create. So you're creating that with the document fragment. You create that element and then append that fragment and another fragment and another fragment and another fragment. You started to see the composition, and then you are now going to apply all of this code that you create on the fly to the element that is pressing on the DOM to load that. So this is something very interesting. You know, Very, very, very interesting. And this is quite interesting because it put now the template here in the head on this metadata here, right? You're not going to use that, okay? I don't want you to render that elements right now. I just want you to hold that elements in memory so we can later on use that at runtime. Good, awesome, perfect, perfect. And what we want to now, for example, is look at another example, and that is the mutation observer, okay, where this actually cover another particular use case, especially useful for text-rich editors, okay. Yeah, useful for text-rich editors or for drawing tools when you want to know when a DOM element actually changed. You want to keep track when this DOM change actually changed based on its attributes, based on its content, which is the character data, or based on one of their child change, okay, which is the whole promise of this. You're going to subscribe now an observer to this element or a group of elements, okay, or a group or a set of elements, okay, and then you want to detect when a change in attribute happened, or a content, or any of the child elements happened. And when that happened, I want you to now do this. I want you to run this callback. I would like to create here in this particular exercise, which I find out very, very, very interesting. Very, very interesting. The mutation here. What the mutation API. That's right. The mutation API. Yeah, the mutation API. To do something like this, so when we hit the bottom, the whole point of this is to implement a basic element here, right? Which means that I just want to implement now a button here. I wanted to put a button here, okay? And when we take, when we yeah, and when we okay, so one of the thing here is that I want to define as a button when unselected, or when there is a section selected with on text selection, okay, I want you to apply now a bold statement to that on the fly. How can we do that? Because this is especially something interesting to do, right? So of course we're gonna define is the bottom, okay, and this button will trigger now is when we want to, as long as there is a text highlighted, okay, we want to apply now under that subset of nodes the ball on that selection. So the thing here is that there are a couple things here to do that, and Perplexity might help us to do this. So how can I implement how can I implement a button that when click it, okay, a button when click it, how can I implement in HTML a button that when click it we want to exactly when click it if there is any text selected, make it bold, you know. So of course it's gonna give us some sort of the thing to do that, define of this, and then say document.exec command bold. Okay. Select some text in this area and click the button to make it bold. Document exec bold. Interesting. When the button is clicked, this command applied the bold formatting to any selected text within the textable area. Oh. Interesting. So MDNN. Oh. But this is deprecated. Exactly. This is a deprecated. Avoiding using it and updating existing code is possible. See compatibility table at the bottom. Okay, copy and cut. Exactly. Say, hey, no. Okay. Let me now tell. Okay, except it's deprecated. Okay, so such command is now deprecated, or the deprecated, the exec command is now deprecated. Provide ESA 2024 alternative. Oh, okay. Window.get selection. Again, this is one of the things here, right? Implemented with the mutation observer. So this is now is the callback, okay? So when the child is changed, I want you to console log this, the mutation, okay? Start observing the content editable diff, and when that happened, okay? And on click, to monitor change, start observing the content editable here. Window get selection. Window get selection. Interesting. But this is from the window. Okay. But this is from the selection API. Selection star, selection change. Interesting. Selection API provides two events, both firing on document. the select star from the node. Okay. Select star and select change. That's interesting. Okay. But in this case, we're going to say something like this. We're gonna do something like this. Is write H1, H2, or H3 to get a heading, to get auto formatting heading. So when we save this and then we do this, when we run this, you say this one, body, entry 1, write H1, H2, or H3 to get auto formatting heading. So when you say this, you actually get that. H1, no, H3. So this is now how you can easily creating this, right? In my case, I don't want to actually provide is this. Yeah, in my case, I don't want to provide this. On the body, I don't want to. When we're creating these elements here and adding that append child. Okay. Observer element here. That's right, but in the title, when we are creating is this. When we are creating is this. On the utils, exactly, it's cloning this, but for some reason it's appending that by say entry 0. Oh, okay, which means that it's on the initial mock is on the utils on the database here. Is for some reason is adding that entry, exactly. Entry 1, entry 2, and that kind of thing. It's okay. It's okay. Exactly. To get out of formatting here, right? So that's why. And not only that, because it's actually looking, it's actually because when we are creating is these elements on the fly, we are assigning is an observer, a mutation observer, that when any of these elements change its content, which is chart data, okay, when any of these elements change, when any of these elements change, okay, when any of these elements change, I want you to now not only get that element, I want to have the ability to, whenever the content of this subtree, which is this card, actually change, right? I want to somehow is to be able to detect those change, and when that change is similar to any of these supporting elements, H2, H3, and H3, H1, H2, and 3, I want you to now replace that element, okay, with the functionality that I'm providing to you. With the functionality that I'm providing to you. So in this case, if I say H1, you detect that. At once, you not only replace that, but keep the focus on that, right? So this is something very, very interesting here. And because you are creating is a mutation on each one of those particular elements that are here, okay? You don't worry about that. You are triggering is all of these elements. You're not worrying about if some elements that you're listening to, that you're targeted to, actually are wrong, because you're only assigning is this element, you're only assigning is this listener to component, per component. So of course you can assign that into a root element, and whenever those change are, you're going to detect that and trigger that, and then you can actually override the content of all of that. But the whole point of this is to understand is what is the logic behind the scenes, as a way to create now this particularly text editors here, right? H1, H2, or H3 to get auto formatting header. In my case, I just want is to not show in that entry. Okay, I don't want to show this entry. Not at all. I don't want to show that entry. Okay. It's because perhaps they're using is that for the sample. Perhaps they're using is that for the sample. Object of from entries. What it's telling you is that, hey, I'm creating is now an object for the entries, where I'm going to map whatever object that this sample. Okay, what I'm going to map is all of the list of property and methods, property and values from this object called sample, and return a new one that contains this. right? And return a new one that only contains the key values in this way. So instead of actually returning is this, okay? Exactly. So what you can do is doing this H1, H2, and so on and so forth. The thing now is the style actually is being applied to a very weird thing here, right? Which is on the get headings is doing in this way. Exactly, heading. And so on and so forth. But this is quite interesting because now the problem that it's solving is that we can now we can now keep track of a state change when that happened. Okay? And I think that's quite interesting. Instead of actually putting a button and then copy and paste that, no. You say here is just, this is if you want to use now shortcuts. Okay? For shortcut, it's like, yeah, good, makes sense, makes a lot of sense, makes a ton of sense. Yep, completely. Yeah, completely. Okay. All right. Okay. Yeah. Good. So, that'll be all for this video. Well, take care. Bye-bye.